All right. If you guys want to shut the door, if the talking's bothering you, you can if you would like to. All right. So starting this first section is called solving rational equations and inequalities. So I think we know what equations and inequalities are. What do you think they mean by rational? What do you think they mean by rational? Rebecca? Okay, we're going to be graphing them, true. Rational kind of like has ratio in it. What do you think that kind of alludes to? Fractions. We're going to be dealing with functions that are equations and inequalities that are fractions. They're rational. So rational equations and inequalities. The graph of the rational function g of x. So it's given here, x squared plus 4x plus 3 divided by x squared plus 2x minus 3 is pictured to the right. So they have the graph of that right there. Use the graph to identify the values for which the following equations or inequalities are true. So we want to look at the graph for these. What is the value of g of x equals 0? So what x value is that at? What x value is the equation equal to 0? Yeah, x equals -1. That would be right, let's see, right there is where she found that point. So we see the equation's equal to 0, the x value was -1 there. Okay? Where or what values are g of x greater than 0? There may be more than one spot. Marie?
It would be -∞ to -1.
Close.
Oh.
Be careful there. We do start at negative infinity.
Oh, -∞ to -1 and then would it also be a comma because I can't write on it?
Okay, you're getting closer. With the negative, we are going to eventually use -1, and it is going to need a parenthesis. But I can't go all the way to -1. Something happens first.
Oh, -3.
There's a hole there. If you look on your graph, we have a hole there. So we have to stop at -3. We can't include -3. And then, does this look familiar to you guys, the union? So both sets. Okay, so we have the union of -3. That's where we're starting. And now we go to where, Marie?
We're going to -1.
-1, okay.
And then we go to 1.
1 to where?
Infinity.
Infinity, yes. So we have 3 different sets there. Negative infinity, -3, union -3, -1, union 1 to infinity. That is everywhere where the function is greater than 0. Okay, let's look and see where g of x is less than 0. From where to where is it less than 0? Very good. -1 to 1. That is the only place on your graph. If you look from -1 to 1, there's this asymptote there. It's all below 0. There's nowhere else. All right, the next one looks similar to something we've done, but it's changed a little bit. We now have g of x is greater than or equal to 0. So how is this going to change? It's going to be very similar to our answer up above. Very similar. -3.
Yeah, sorry.
It's okay.
And then -3 to -1 is the graph.
Okay. Now what's next?
And then we do 1 to infinity.
And be careful, we have to include the 1 in a bracket also.
I forgot that.
Yeah.
How come we didn't put the first one in the bracket if it's still not that?
Let's see here. So g of x greater than 0.
Like,
Yeah, I guess technically as the asymptote, it's not going to ever touch. It's going to come very, very close. So if you'd like to, you could technically leave that as a parenthesis. But it's going to come very, very close to it. But yeah, it's truly never going to actually touch it. But let's see. It's a -1. I guess if you know, because we're saying greater than or equal to 0. I guess that would work, leaving it like that. All right, now g of x less than or equal to 0. So similar to your answer up above, what would I have to change this time? Somebody I haven't talked to, help me with this one. And what with the 1? Yeah. Very good. -1, comma 1, bracket around the -1, parenthesis around the 1. So far, I don't think that's too bad. I think we're able to look at a graph and able to find these. Just make sure that if you have a hole, you don't overlook something like that, and pay attention to your asymptotes. Okay, the goal of this lesson is to learn a strategy to algebraically solve rational inequalities. The process is identical to solving polynomial inequalities with one exception. Given the function g of x, so this function from up above, find the function values g of -3 and g of 1, show your work. So here, all they want us to do is plug in g of -3, and we're going to show our work for this one. So -3 squared plus 4 times -3 plus 3. -3 squared plus 2 times -3 minus 3. Get a value for the top, get a value for the bottom. Don't type it all in your calculator at once. Just get the top value, get the bottom value, and we'll write both. I have the top value. What did you get for the bottom value? 0. Okay. So what is this answer if we get 0 over 0? We kind of have like two ideas going in our head, but what is our actual answer for this one? If you're not sure what the answer is, what are our two scenarios that it could be looking at this? Okay, so how would it be an open circle? What do you mean by that? Okay, so how do you know nothing's occurring there? Like what from your answer is showing you that? I agree with you, you're heading in the right direction. Yeah, this is what's throwing the whole problem here. Okay, this is what's causing what Marie was talking about. We have a 0 on the bottom. No matter what's on the top, we can't have a 0 on the bottom, so this is undefined. So that was at g of -3. So at -3, we're saying our graph is undefined. Okay? And we're going to go back to that in a moment. Now show the work for g of 1. I know I didn't leave a lot of work, but I'm going to try to squeeze it, or a lot of room. I'm going to try to squeeze it in here. So g of 1. Did anybody get a value for this one? Top, bottom, or both? 8 over 0, so the answer is what? Undefined. So we're saying at g of 1, we're also undefined. Okay, so the next part says, using the graph above, explain why your efforts to find the values of g of -3 and g of 1 had the outcome they did. So why do you think they had the outcome they did? We're going to put a formal explanation down, but just your own ideas. What do you think's happened?
It's not possible for a point to
For what?
a point
Where are you talking about right now? There's not possible to be a point where?
on the one because there's a hole
Okay.
cut in the hole cut and the other one is because of
Yeah, some toad.
a
Okay. So we have both of those. Graphically, we can see that, but we need to actually determine now why from the actual rational equation or inequality that it is true. So first we're going to say, when the denominator and we're going to list out the denominator, that's x squared plus 2x minus 3, is factored, the result is what is the result if I factor that? If I factor this right here, the x squared plus 2x minus 3. If I factor that, I get what? Yeah, x plus 3 and x minus 1. Okay. When x plus 3 and x minus 1 equals 0, then x equals -3 or x equals 1 are undefined. So the graph must be what at these points? Must be at those 2 points, the graph is what? Word starts with a D. Anybody have it? The graph must be what? Anybody have it? Gonna pick someone. Dylan, do you have it? No idea? Not at all. So if we look at the graph at -3, what's happening at that point? The same thing that would be happening at 1. The graph is of what? Starts with a D. Discontinuous. Yeah, exactly. It's discontinuous. We don't actually have a point at that part in the graph. So the graph must be discontinuous. At x equals -3 and x equals 1. So when the denominator is factored, those factors equal to 0 are undefined, so the graph must be discontinuous at those 2 points. That's what we're describing there. Now remember, that's the denominator. When we factored the denominator and set the denominator equal to 0, those pieces made the graph undefined. Alright, that's important as we move along here. So completely factor the function. Again, the same one from up above. Identify the values of x that make the function equal to 0. and the values of x which make the function undefined. So let's go ahead, just in some open spot here, we are going to factor it. We know the bottom was x plus 3 and x minus 1. So we already factored that. But we need to factor the top part there. So the x squared plus 4x plus 3. So the top factors to what?
X plus 3 and x plus 1.
X plus 3, x plus 1. Okay, very good. So let's skip this part for a moment, where it's equal to 0. We've already talked about g of x being undefined, and we discussed it in the problem above, and the problem above that, and we talked about it graphically. So what are x values where g of x is undefined? We've talked about it numerous times so far, and we proved it in the example right above. X equals negative 3 and 1. Okay, those are the two places where it's undefined. What's happening at the negative 3 spot that's causing the discontinuity? What is happening at that negative 3 spot? There's a hole. Okay, very good. What about at the 1 spot? What's happening?
The asymptote.
Yeah, vertical asymptote. And if you want to make a note of this, g of x is undefined when we're dealing with the rational equations and inequalities. That means your denominator is equal to 0. So if you just want to make yourself a note, but that's what we showed up above. So the denominator is equal to 0. Okay. Let's try to find out when g of x is equal to 0. So we found out when it was undefined. Remember, we set the bottom equal to 0, and we were able to find that. So let's look now at the numerator. When is g of x equal to 0? When is g of x equal to 0? At what x values? Where is g of x equal to 0? Okay, negative 1. I agree. What about the x plus 3? Any idea what happens with that? Hannah, do you think that's a 0 or no?
No.
Okay, so she says no. I agree with her. What happens that causes that one to not be a 0? We may have proved this earlier in the notes already today. What happens with this one that causes the problem? Rebecca?
The factor of the denominator, so therefore it would make the equation undefined be at x minus 3.
Exactly, so we would get that 0 on the bottom. So when you're looking at g of x equal to 0 and you're checking your factors, you have to have a numerator equal to 0, but denominator has to be not equal to 0. So you cannot have a denominator equal to 0. In this case, we have the x plus 3 and the x plus 3 on the top and the bottom, so that would cause the 0 on the bottom, and that cannot happen. So only negative 1 causes g of x to be 0. Does that make sense? If you look up above, we showed that there. We got 0 over 0 for that negative 3, so that was undefined there. All right, let's go ahead to the back. So as we said, we're going to find a process or like steps to solve these rational equations and inequalities. So we're going to start through these steps. We're going to do this one example. We're going to work through a few that have the steps laid out for us, and eventually we'll take these steps away and we'll be able to do it without the steps. But the steps are going to help us get started and learn the process. To solve rational inequalities, the process to follow is identical to the process previously learned to solve polynomial inequalities, except in the case of rational inequalities. We must not only divide the number line for the sign analysis using values that make the function equal to 0, but also using values that make the function undefined. So like we did on the front, the factors on the top and the factors on the bottom, the denominator. So first step, it says completely factor. One moment. Morning. I do. Yes, I can. All right, bye. Where are you, Mr. Scott? Need you? He's in his office. All right, so we need to completely factor the given rational function, provided that it is not already factored. So if we look at it, it is not already factored. So let's go ahead and try to factor it. We need to factor the top and the bottom. So I'm going to write it over here so I have a little more room. Okay. What do we think the top's going to factor to? What do we think the bottom's going to factor to? Or is this the same one that actually we used on the first page? I think it is, isn't it? All right, so let's use the factors from the front of the page. X plus 3, x plus 1, x plus 3, x minus 1. So that's step 1, completely factor what you're given. Step 1's not too bad. Step 2, set each factor equal to 0 to find the zeros of the function and the values where the function is undefined. Draw a number line that is divided into segments using the zeros. So we know the zeros, where it's 0 or undefined, are the x values of -3, -1, and 1. That's our list of numbers that either make it undefined or 0. That was the first part it said. So set each one equal to 0 and find those values. Next it wants a number line. So we're going to draw it something like this. We're going to put -3, we'll put -1, and we'll put 1. So it doesn't have to be spaced exactly right, but so you get the general idea of where the numbers are. Okay, so it said to draw a number line that is divided into segments using the zeros. So that's part 2. Part 2 is done. We found the zeros or where it's undefined, and we drew the number line. Step 3, we can see it's still blocked with the number line part, so we're going to be using that number line. Choose a number from each interval and determine the sign of each factor of the rational based on the chosen value. This will enable you to determine if the entire rational is positive or negative on the interval in question. So we want to determine in each of these intervals if it's positive or negative. So we need to choose a value within these intervals. So from -3, so we can pick any value. Let's pick, let's say x equals -10. That's within this. So if I plug in -10 up above, we're going to go through a process. It might make it a little easier. All of these terms, top and bottom, they're being multiplied, or top is being multiplied and bottom is being multiplied. So let's just think about each individual term if you plugged in 10, instead of actually finding the number value. We just want to know, is the final answer positive or negative? So if I plug in -10 here to the first factor, is it going to be a negative number or a positive number? It will be a negative number. If I plug in -10 here, what do I get? A negative number. So on the top, I'm going to have a negative times a negative. On the bottom, if I plug in -10, I'm going to get a negative here. If I plug in -10, I'm going to get a negative there. So again, I would have a negative times a negative. So on the top, a negative times a negative becomes a positive. And on the bottom, a negative times a negative becomes a positive. So my answers in this interval are what kind of numbers? Positive numbers. Okay, let's try a number in between here. So x equals -2. If I plug in -2 here, I'm going to first get a positive number. And if I plug in -2, I'm going to get a negative number divided by a positive number times a negative number. Positive times a negative is a negative over a positive times a negative, which is a negative. Negative over a negative is a what? Positive. Okay. A value in between here, well, x equals 0. And I'm going to pick x equals 10 for this last interval. Go ahead and check these two on your own. So the same process we did for the first two. Check with 0 here and check with 10 here and see what these two intervals are, whether they're negative or positive. All right, for this interval, after you simplify, did we get negative or positive?
Negative.
Negative, okay. For the last interval, did we get negative or positive? Anthony? Positive, thank you. Okay. So we went through that process and we found out what the answers were going to be within the intervals. If we think back, this one, or we're looking for anything that's less than or equal to 0. Well, we have positive and positive here, so negative 3 is not part of that. And we found out before in our other problem that that was undefined because it's on the top and the bottom. So we're not going to include the negative 3. The 1 was also on the bottom, so it was undefined at that point. But this was 0, and remember, we're looking for numbers that are less than or equal to 0. So we're going to include number 1. Remember, that's from the top factor. We're going to include the negative 1 and this interval here. So let's look what number 4 wants us to answer about the graph. The graph there, the number line. Refer to the original inequality sign. In this particular example, the inequality symbol is less than or equal to. So that's what I was just referring to at the top of the problem. Which means the solution will be the values that make the polynomial negative or equal to 0. Write the solution interval or intervals. So we know less than or equal to 0 means g of x equals 0 or is negative. Okay, so the interval is what? Use your number line above. Use what we know about this problem. Where is it less than or equal to 0? Again, I know we have the graph on the front page, but we're trying to answer just from looking at this, so without looking at the graph, just the steps we've done. What interval is it equal to or less than 0? Rebecca?
Bracket negative 1 and comma 1 with a parenthesis.
Very good. So we know negative 1, that's where it was equal to 0. And everywhere in between negative 1 and 1, it was negative. We found that it was negative here. So that's where it is less than 0. So from negative 1 to 1. Somebody get the door, please. Thank you. All right, very good. So those are the steps we're going to follow. Lastly, now refer to the graph of g of x pictured to the right. Explain how your sign analysis in the process above, so what we just completed, is confirmed by the graph. So our answer was that we said it was less than or equal to 0 from negative 1 to 1. If you look at your graph, does that make sense? So it says from negative 1 until 1, it's less than 0. Less than or equal to 0. Well, graphically, that does make sense. So less than or equal to 0 graphically means on or below the x-axis. And g of x is on or below the x-axis on the interval -1 to 1, bracket, parenthesis. So right here is the only spot that it's on or below the x-axis. Any questions about the rational equations or inequalities so far? So the big part's just going to be determining when it's undefined and when it's equal to 0 and being able to distinguish between the two. Alright, that's where we're going to stop for today. We're going to leave the rest of them for Tuesday since you don't have school Monday. That way you have a refresher when we come back.